So you should see a picture of some panels and some people and some. So when Jock asked me to put this together, I just grabbed some pictures. I mean, it's obviously they're just solar panels and because generally speaking, the majority of solar pumping is submersible pumps, obviously extracting groundwater. But we do a bit of surface water pumping as well. But I'd have to say in Australia, it'd be probably around the 70% mark submersible pumps and then 30% surface mounted pumps. And of course, you don't get much of a picture of a pump in a bore. It's just a hole in the ground. But so these are examples. The top left-hand corner is a site in Albany in Western Australia, actually the one below it as well. So that's a pumping system they're using. It's pumping from a tank and it's supplying stock water to a cattle station in Albany. And the top right-hand corner, that was an interesting experience. I was fortunate enough, it was about 3 years ago, to travel to Samoa. And Samoa is an interesting place. They basically run off diesel power, is how they generate energy over there. So they've started to introduce some solar pumping systems. So that was a system we did for water supply to a small Samoan community. That was up on top of the hinterland, beautiful little country. So that was a nice little system. And then the one in the bottom right-hand corner is utilizing, so you're just seeing some pictures of some controllers. It's basically on the left-hand side of that bottom picture. Actually, my arrow might help if you can see my mouse. But you've got the solar inverter here. The big box in the middle is a changeover device. So it's an automatic changeover system that can go when the sun intensity drops below a certain level, it will switch from DC to solar across to AC, where it will start up a generator to take over. So that was on an irrigation system in Western Australia. So there's just some quick examples of some solar systems. When we look at solar pumps, they're broken down into a couple of categories. We have submersible pumps, which, as I said, represents probably around 70% of the market in Australia. And in those two categories, there's two types of pumps. We have on the left-hand side there, you'll see it's a slightly different design. It's got this worm-style rotor, which we call a helical rotor. The design works well in solar pumping, especially on low sunlight days, because it's referred to as a positive displacement pump. And the idea is, as long as it's turning, so as long as there's enough sunlight to power up the motor, the pump rotates and it will then deliver a minimum amount of water. So in those low sunlight conditions, the helical rotor pumps are a lot more efficient than, say, the centrifugal pumps, which is the one next to it. So for low flow, high head applications and low sunlight areas, the helical rotors are the pumps of choice by most manufacturers, and generally used in those smaller areas. Stock and domestic is probably where you see a lot of them. As we get into bigger pumps, we tend to switch to centrifugals, and the centrifugals, and I'm assuming people understand the difference between centrifugal pumps and helical rotors, but maybe to put it in one term, if you can think of the centrifugal has got what we call an impeller that rotates and needs to achieve a certain speed before it can deliver the water out of the bore to overcome the actual head pressure. So when it comes to higher flow rates, we switch to centrifugal pumps because they're good at pumping volume and head at reasonably low levels. So we don't want to, we're not going to do the really high lifts, if you like. So if you're trying to overcome a 100-meter hill or something like that, then a helical rotor would probably be better suited, and the centrifugals then better suited for larger systems. And then when we get into the irrigation applications, we generally 100% centrifugal. Then we have our surface-mounted pump types. And here's just a couple of pumps. They can be as small as just a small, what we call horizontal multi-stage. It's got a bunch of impellers in there, reasonably efficient, ideal for small flows. And then we move to what we call a vertical multi-stage. So these would be just sitting on the banks of a dam or a river or next to a tank and pumping water. Generally speaking, when we move to surface, some manufacturers have integrated motors with inverters, but most of them run an external inverter, and I'll explain that a bit more in just a tick. And then we can run, and what the inverter allows us to do is then run basically conventional pumps. So the pumps aren't anything special. They're basically the same pump you'd run on a grid system. But we use an inverter, which is, there's a picture of one there, and that allows us to convert the DC power to AC and then run conventional AC motors. When it comes to the actual motors, the technology is a little bit different. And so motors, we've got submersible motors, and then we've got surface-mounted motors. In these submersible motors, up to around 4 kilowatts, it's broken up into 3 types of motors. And without trying to get too technical here, essentially we have permanent magnet motors, which tend to be the higher efficiency type motors on the market at the moment. They can convert AC, convert directly by the inverter built into the motor. So what we actually have, so I'll go back a step, is we've got the motor, stator and rotor, which is at the top. And then we've got a bunch of electronics that's actually mounted in the motor itself. And it's basically a built-in solar inverter inside the actual motor. Like I said, up to 4 kilowatt. And what that'll do is take AC or DC directly into the motor, so it can run on solar, and then you can switch over to AC during the nights or as a backup if you haven't got enough sunlight. Permanent magnet, what we mean by permanent magnet is normally with the motor, you have magnets in the stator, and then the rotor is just a bunch of copper windings. In this case, we actually put magnets in the rotor as well. So it's basically a full magnetic motor, which makes it more efficient. It tends to run cooler. And then with the electronics, we then have the ability to control that to run either AC or DC. From there, we move on to the brushless DC motors. Can operate at quite high speeds. They provide a good constant torque. They run purely on DC. Mind you, you can have a transformer up the top that converts AC to DC, and then you can run them that way, but then that's an extra expense to do that. So basically DC to DC. It's a little bit of an older design, but the advantage is they tend to be a little bit cheaper, so they're good from that point of view. And you tend to see a lot of the internet sellers using this style of motor. There is a bunch out there, but yeah, I think personally the permanent magnet's the way to go. And then of course we've got conventional induction motors. So these are the types of motors you'll see on your standard range of submersible borehole pumps. So they can run either AC or DC. And how they're controlled from a solar point of view is we use an inverter, and the inverter converts the DC from the solar array to AC, and then these motors are just a standard induction AC motor. And then when we move to the surface-mounted motors, we're using conventional induction motors. So these are the types of motors you'd see on your normal irrigation pumps out in the marketplace. So with the inverters, we convert the DC to AC, and then we can just run the conventional 3-phase motors or single-phase motors. from there, you can go up to kilowatts. You know, there's inverters and motors. Obviously, I put a number in there, 250 kilowatts, but they can go bigger than that. And I'm sure there's examples of solar systems bigger than that. But yeah, so and this is just a quick picture of a system layout. So essentially, we've got the solar array, which would be sized to the application. I tend to stress that because there are a lot of internet sellers trying to sell solar pumps at the moment, and they're giving very generic information, and customers are, I think, getting one of a better term, sucked into the lower price. But really, you know, these systems have to be sized for the application. So what I mean by that is how much water they really need for if it's livestock or irrigation, working out the hydraulic losses in the pipeline, the heights they have to overcome. So, you know, those pumps have to be sized to make sure they can achieve that. And if they're not done correctly, then I think you'll find the customers will be really disappointed. So essentially, we've got the solar array, an inverter, or if it's a pump with an integrated, and the smaller motors with the integrated permanent magnet with the controls, then it's just straight from the solar array down to the motor. They'll obviously have some sort of DC isolation to be able to isolate the pumps from the array so they can pull it up and work on it. And some companies have some controls so then they can run pressure switches. So when the tank fills up or the stop trough fills, and the system will shut down automatically. And then when we get to the bigger systems, we've got external inverters and running conventional pumps. So that would depend on the size. So as we get bigger, we tend to move away from the integrated solution to an external inverter. I just put this slide in. So these are the sort of challenges we sort of see in the marketplace when it comes to solar pumping. And I emphasize this, but it's a big thing. It's correctly designed systems. You know, a lot of people, like I said, with the internet sellers, tend to think a system will work and under all circumstances, but correctly sizing a system to suit the application is critical. So making sure you've got all the calculations for friction loss heads and the amount of flow they need, and making sure, you know, is it the worst case scenario they're allowing for? You know, some people might decide that they want the flow in peak summer, some might want it in peak winter. So understanding the application and sizing the system correctly is critical. You know, making sure you've got enough water. So at no point saying I need 10,000 litres a day if the bore is only capable of producing 5,000, and you overpump the bore and the pumps then run dry, and then of course that could cause some issues with the product. A correctly sized system, I've said that. The array frame design, obviously there's some companies out there that are specialised in array frames, but there's also people out there that will just make their own system up. They do have to be careful. Obviously, structural strain standards for structural wind loadings and soil types, then the array frame has to be certified for those applications. You don't want the thing falling over or blowing away and causing some issues. So, a good array frame is critical. Dealing with someone that provides the installation and the commissioning. Yes, I put in there backup AC. When we get to, this is a contentious issue in solar pumping at the moment, and me and Jock spoke about it briefly when we caught up the other day, is more about when we get to larger systems. So as we move from stock and domestic, the great thing about stock and domestic is that the energy source is at its most available when the stock are drinking the most. So the hotter the day, the more sun's out there. So the pumps tend to suit the application quite well. When we move on to larger systems, that we're talking about irrigation or water supply, then the continuity of supply is pretty critical, and they can't really afford to have a drop off because some cloud covers come over. And what they do is they want to have some backup systems. They want those backup systems to be automatic. And then there's some challenges. So if the automatic backup system is from mains power, it's fine. You can switch over and you can blend, which is a term we use at the moment. So that's where you use predominantly DC and you blend a little bit of AC into the system. But if you're using a diesel backup, a diesel generator backup, then there's challenges because you don't want to be partially loading diesel generators because that causes issues with the actual generator itself. Being partially loaded can cause the force to glaze up. And then you're talking about adding additional load to the generator. My experience is the best way to do it is to switch from one power supply to the other directly. So you either run all AC or you switch across to DC and you run all DC. So rather than doing the blending thing, there is some, I know the Clean Energy Council has some issues with blending and they've written some standards around that. But some people do blend, and I have some of the feedback I've got from manufacturers of inverters is that the inverters do suffer as a result of using the two power supplies into it. I don't understand the technical aspects of the actual reasons behind that, but they do say it can degrade the life of the inverter by blending. So my personal experience is you switch from one power supply to the other power supply cleanly, use a properly designed system, and you won't have any issues. The other things, obviously, which are critical is the support and backup. Solar pumping is a specialised product and does need that support. And obviously, if you're dealing with a particular retail and making sure the manufacturer, then obviously warranty is important to make sure you can get that back up long term. And the other thing I just wanted to point in is avoid online resellers at all cost. That's something we're hearing quite a few horror stories out there, incorrectly sized system or product not working and that type of thing. So